Okay, today we want to look at the standard equations of hyperbolas with the center other than the origin. In other words, the center is HK. So first, it's very similar to what we've already done. If we have a horizontal transverse axis, all right, horizontal transverse axis, the form of the equation is x minus h squared over a squared minus, y minus k squared over b squared equals 1. Notice the only difference, before h was 0 and k was 0 when the center was at the origin. So that is the only thing that has changed. Our vertices are h minus a k and h plus a k. If you just think about whether you have the horizontal or vertical transverse axis, it's easy. You don't really have to remember the formula. The foci are h minus c k and h plus c k. And the asymptotes are y equals k plus or minus, in this case, change in y over change in x, so it's b over a times x minus h. Those are the equations for the two asymptotes. So if we want to kind of look at what that might look like, let's say that our center is right here. Here's our center HK. Our vertices are h plus a k and h minus a k. The foci are going to be h plus c k and h minus c k. If we were to graph the asymptotes, you can always graph the asymptotes from the center point, and then all you have to worry about is the slope. So if this is going to be b over a, let's just say it looks like this. And so our asymptotes would be here. Easy. You may need to give me the equation for the asymptote, but when you're graphing it, graph it through the center point, and all you're looking at is the slope. Okay, and there is our hyperbola with a horizontal transverse axis. The center is HK. The vertices are h minus ak, h plus ak, foci h minus ck and h plus ck, and then the asymptote. So let's look at the vertical transverse axis. A vertical transverse axis. Remember, if it is vertical, y comes first. So we'll have y minus k squared over a squared. A squared with a hyperbola is always first. Minus x minus b squared. I'm sorry, not b. X minus h squared over b squared equals 1. And remember up here, c squared equals a squared plus b squared. Just like when the center is at the origin. This time our vertices are going to be h k minus a and h k plus a. Our foci are going to be h k minus c and h k plus c. And our asymptotes are going to be y equals k plus or minus change in y over change in x, so this time it's going to be a over b x minus h. And again, c squared is a squared plus b squared. So if we were going to graph this, if our center is hk, this time our vertices are going to be, the h is going to stay the same, and we're going to have hk minus a, hk plus a, and then we could graph our foci, hk minus c, hk plus c. And if we were to graph our asymptotes through the center point, this time it's going to be a over b. We could go up a over b, down a over b. Notice you get a rectangle. And this just helps us determine how wide or how thin our asymptote or our hyperbola opens. So this is a vertical transverse axis. Okay, not that much different from what we've already done. So let's look at a couple of problems. Okay, here we have the equation of a hyperbola. I want to find the center, the vertices, the foci, the asymptotes, and then we want to graph this hyperbola. So we're going to have 4y squared. Notice that's positive. I'm going to group together the y's, plus 24y, minus x squared plus 4x equals negative 28. Okay, here I have to factor out the 4. And we'll have y squared plus 6y. Now notice this is minus, so I have to if I'm going to put the minus in front of the parentheses, this is x squared, this becomes minus 4x, because a negative times a negative is a positive. So we have to factor out that negative from there. Okay, and this equals negative 28. We take half of this term, square it, and I'm not going to add 9, I'm going to add 4 times 9. And over here we take half the middle term and square it. Sorry about that. And this is 4, but we're subtracting 4 from both sides. So we're going to have 4 times y plus 3 squared minus x minus 2 squared equals negative 32 plus 36 is 4. So if I divide everything by 4, we get y plus 3 squared over 1 minus x minus 2 squared over 4 equals 1. Now in your homework, I expect to see the standard equation, not just listing of the center, the vertices, the foci, and the asymptotes. This standard equation is also part of the requirement that I'm looking for, because you can't really figure out everything else if you don't have it in standard form. All right, so we know that this is a vertical transverse axis. So we can find our center. Our center is the point 2, negative 3, HK, remember. A is 1, B is 2, so C is A squared, C squared is A squared plus B squared, so C is going to be the square root of 5. All right, so if we think about our vertices, it's a vertical transverse axis, so it's the y that's changing, so the 2 is going to stay the same, and we'll have negative 3. We can just do that one. I was already thinking about the foci. All right, we'll have negative 3 minus 1, which is negative 4. and 2, negative 3 plus 1. So that's going to be negative 2. So these are our vertices. Our foci are going to be 2, negative 3 minus the square root of 5, and 2, negative 3 plus the square root of 5. All right, now we want to find the equation of the asymptotes, and this is going to be y equals k, which in this case is negative 3, plus or minus a over b, change in y over change in x, so plus or minus 1/2 times x minus 2. Okay, so that's the equation of the asymptotes. Now let's see if we can graph this. Okay, we said the center is 2, negative 3. Our vertices, do that in a different color, is 2, negative 4, and 2, negative 2. Negative 3 minus the square root of 5 is approximately negative 5.2. Let's see, 1, 2, 3, 4, 5, so right here. So negative 3 plus the square root of 5 is approximately negative 0.76. So let's say about here. Now, the slope is 1/2. So from the center point, I'm going to graph two lines, one with the slope positive 1/2 and one with the slope negative 1/2. Okay, so we go from the center up 1 over 2, down 1 over 2. Up 1 over 2, and down 1 over 2. So if we graph the asymptotes, our hyperbola looks like this. And we have just found everything that we needed. Remember, in your assignment, I'm going to need to see this equation if it's not given to you in standard form. Okay, I want to give you just a little bit of information just for future reference. If you're asked on a SAT or AC test to determine what kind of a conic you have, the general form, the general equation for a conic is ax squared plus cy squared plus dx plus ey plus f equals 0. Now notice, if you only have one term squared, you have a parabola. If only one term is squared, it's a parabola. If A equals C, then you have a circle. If A times C is positive, you have an ellipse. But if A times C is negative, you have a hyperbola. Which makes sense because a hyperbola is the only one where you are subtracting one of the terms squared. So this is just some extra information. If y'all run across it, some of you will be taking probably the SAT or ACT later this summer or next fall, and hopefully you'll remember that. But this is probably the main thing to remember. If you have a minus x squared or a minus c squared, you have a hyperbola. If you only have one term squared, you have a parabola. All right. Your assignment, this will be assignment number 15. On page 745, 14, 16, and 26 to 32, even. Remember, if you are not given the equation in standard form, and I think that's going to be on these, I need the equation in standard form. Not just the list of stuff it asks for, but I also need to see the equation in standard form.